Right, good evening. This is Mr. McCarron again, going to do the second video about the June 2015 Greenfoot scenario. Now I've come home, so this is my home PC. It's very different to the school one. This is the second video of the June 2015 one. I think in the first one I sort of forget, but I think in the first one I went through this scenario and I talked about the classes and which category of game they were in. And I think also I did populate the world, the ocean class here. So let me just start up from the second task, well, task C actually. Let's do 2015 and go down to the Greenfoot task is here. Okay, now there's the actual questions, and let me open up this scenario. Now I do have this is a fresh copy, so I haven't done the populate of the ocean class, the world, in this one yet. So let me just quickly whiz through that again. So I'm going to delete the populate method. I don't need that. Only need one of these. Prepare or populate will do the job. Let me make ship quickly equals new ship, and then add object ship. I see already my first mistake. I have to, that won't compile. Okay, at least it shouldn't compile. Where's my error message on this one? Okay, let me close this down. Compile. Oh, which version? This is a different version of Greenfoot, so I don't have the compile button down here, and I had that. Ocean isn't compiling. I'm sure you can all see why, but I want to see my error message. Next error, there it is. Can't find symbol ship. Okay, because in this version I've still got ship with a small s, and I explained last video that should be a capital S. Okay, right. There's the ship. Let me just quickly, I'm sorry this is repeating the old stuff. Just make some icebergs very, very quickly. Bear with me, please. This won't take me long. Equals new iceberg. Spelled correctly. Add the object of the new iceberg. Iceberg 1. Add 2. Okay, let me copy and paste these lines. Fast forward through this, yeah, if I'm boring you doing the same old stuff again. Iceberg 2, add iceberg 2, and iceberg 3. Okay, add iceberg 3, save that, Control K, compile it, no compilation errors. Reset this. I see my mistake. I haven't changed the coordinates of icebergs 2 and 3. Put that at 3, 3. Put this at 4, 4. And I should have 3 icebergs, 1 ship. Right, there we go. So now I'm going to do this task C, which is edit the icebergs so they turn and move randomly. Now, I mentioned, I think before, we noticed in this iceberg class there's a lot of code given to you already. Okay, there's the act method is where you put your instructions for your exam. Now there's extra methods here. There's a move method already in the iceberg class. We can see what that does in a minute. There's a can move method which gives back a boolean, a true or false. This does something and gives back an answer true or false here. Returns false, returns true. Okay, we'll see what that does in a minute. Turn left. Okay, a method to turn the iceberg left, and a method to set the direction of the iceberg based on a numerical value. Set direction, it's an integer. Okay, so let's see what all of this is doing now. Now, at the very, very top of this iceberg class, we see there's 4 private static final int. So int means it's a number. Okay, east is an integer. It's a variable called east with a value of 0. I just said variable. It's not a variable. It's actually a constant because it's final. You cannot change the value of this constant called east. It's fixed at 0. Okay. Same for west, north, and south. So the points in the compass have been given numerical numbers: north 2, south 3, east 0, west 1. Okay, final means it's a constant, you can't change it. Static means there's only one copy of this value for every single iceberg in the game. I've got 3 icebergs, they will all share the same value. Okay, you can't change it, and it's one share between all the icebergs, whereas each individual iceberg has its own direction. You can't change it, and it belongs to that one iceberg. Okay, it's not final, it can be changed, it's not static, therefore it belongs to each individual iceberg object. Okay, right, now when you make a new iceberg, it's automatically the direction is set to east. Right, so it's going to make a new iceberg, set direction, it's going to jump down to the set direction method with the value of east. So set direction has the direction of east, which is 0. Okay, now then we have this new concept in Java. I haven't done yet in lessons, but it's very straightforward. You're going to switch direction and then check what it is. Switch in case. Now basically what a switch in case structure does, you pass it in a value to the switch, and based on what this value is, you will do something. So if the value of direction is south, it's going to set the rotation of the iceberg to 90 degrees. Okay, i.e. remember that south in this game is going to be going down, so it's going to set the direction of the iceberg to be 90 degrees, right? Then east is going to be, the rotation is 0. Okay, I'm guessing that means that the set rotation method, let me just check this in the Greenfoot documentation, the Greenfoot class documentation, the set rotation method of an actor, okay, it's down here somewhere. I want to see what the default rotation in degrees. Yes, so 0 degrees is to the east right hand side of the world. Okay, so 0, Greenfoot does things a very odd way sometimes. In normal geography, normal maps, whatever, 0 degrees is vertically up to the north. Here they put 0 degrees to the east on the right. Okay, and it increases clockwise. So for some reason they've put 0 is going this way. I don't know why they've done that. Okay, it should be going up, but they put it going to the right. So 0 degrees means going to the right, going east. Right, so back to the code. South in this case is going to be 90 degrees going down. That's 90 degrees going down for south. West will be 180, I guess. Yeah, and north 270. So it's going to go the whole. If you're going this way, around there means going up. I hope that makes sense. Yeah, because east is 0. South is 90, west is 180, north is 270. So depending on what value this has, if it's 0, 1, 2, 3, 4, 0, 1, 2, 3, excuse me, it's going to set the rotation of the iceberg based on that value. Now it starts off with a direction, default direction is east, so it's going to be going right. Okay, we can check that actually right now. If I actually am here, if I just if I type in move, let me just check that. If I type in move, okay, the move instruction, it's going to go from here down to this one, this move method, and it should just move all the icebergs. You just move right across the screen. If I run this, yes, they do very, very quickly, but they move right. Let's reset that. So basically what happened there is that we've called this in the act method, we've called the move method. The control jumps from here to here. Now then, if the iceberg cannot move, okay, if it's stuck in a location where it can't move, it's going to leave this method. Return return means leave this method. Okay, jump out of this method back to where you were. So it will go back from here back to there again. Okay. Now, if it can move, it's going to change. It's going to do another case, right? Based on the current direction. The current direction, remember, is east. We haven't changed direction yet. It's still east. So it's going to go through these. Case south, no, I'm not going south. Case east, yes, I am going east. So set the location of my current x coordinate and add 1. Okay? Current x coordinate and add 1. The y stays the same. Right? Now we can change direction. Let's just try that. Let's try and change this direction before we move it. Let's try and set it. Set the direction so they go down. Okay, so set direction south, S-O-U-T-H, capital letters. Save that, compile it. Now if I run this, these icebergs should all move down the screen like that. Okay, very, very quickly, but it works. So these methods, you can use them inside the iceberg class to do things if you want to. Now, the can move method, I guess, just checks like we did before. It's going to check the width if the iceberg is at the edge of the world. So if its x coordinate is above the width of the world, or the y coordinate is above the height of the world, it's at the edge of the world, so it can't move. So that means it cannot move. Return the answer false. If the x coordinate is 0, i.e. it's off the edge here of the screen, or if the y coordinate is 0, it's off the top of the screen, again it can't move, so it's going to return false. Otherwise it can move, return true. Okay. Remember, in this game, this screen, there's only 8 coordinates, from 0 to 8 top to bottom, and 0 to 8 left to right. Okay. Now the last one is turn left, where depending which direction the iceberg is currently facing, if you turn left, you've got to work out which way you'll face next. So if the iceberg is facing south, going down, it's facing this way, and if it turns left, it's going to actually go east. Okay. If the iceberg is facing north, going up, and it turns left, it's going to go west. If it's facing west and turns left, it will go south, etc., etc. Yeah. So if it's facing west, it will go south. North, it will turn west, etc. So this turn left depends on which direction it's currently facing, and then it will go to the new direction based upon that. Okay, another switch in case. Right. So this one, it looks quite complicated when you first see it, but it's actually, there's a logical sense behind it. Yeah. Now, what the question says is we have to edit icebergs so they turn and move randomly. Now, you can, there's 2 ways to do this. There's the way we did in lesson and we did in the Pizza Boy game. You can, of course, just do exactly the same thing. We move it, say 4, and then we can do a random number generator, and occasionally we can make it change direction if it's above or below a certain number. So we can do that. I'm going to do int random number, okay, equals Greenfoot dot get random number. Excuse me, typo there. 100. Right. Let's save that. Compile it. Okay. Let me just run that and see what happens. I just realized something. If I run that now, yeah, it goes there in one massive long leap. I think 4 here, move 4 means move 4 squares. Let's just move it 1 at a time. 1 square at a time, not 4 squares. If there was no tiles here, it was a normal background, we could move, say, it's going to be a few hundred pixels wide, but at the minute it's just 8 tiles wide, so let's just move it 1. So if my random number, let's set up the empty if statement, another keyboard. Typo, this keyboard's a bit smaller than the school keyboards. If my random number is less than 40, so 40% of the time I'm going to turn, say, actually let's do another random number here, int random angle, okay, equals Greenfoot dot get random number. Okay, and again we'll do that as, well, let's do it as 360. Okay, there's 360 degrees in a circle, so my random angle is going to be between that, and then I'm going to just turn my random angle. Okay, so let's save that and run that and see what happens. Wow, look at that. So the icebergs are whizzing. There's only 3 of them, but it looks like there's 30 of them. It's whizzing around the screen very, very quickly there. So it's far, far too fast. You can, of course, slow that down with the speed slider, right? Like that. So technically, that actually is enough, I think, to get you the marks for that question in the exam. Okay, they are moving, and they are moving randomly, and they don't get stuck on the edges either. Okay, so that will work. I mean, it's not the most elegant solution because it's quite quick. We can actually slow that down as well. Let me show you how to slow this down. If we go outside the if, we can just do a Greenfoot. Let me just check the documentation for this. Actually, under the Greenfoot class, there's a delay method, which int time. Okay, so if I put in Greenfoot dot delay, let's say 1. Is that 1 second? I'm not sure. Let's run this and see what happens. Okay, so it's a bit slower. Okay, a bit slower. Let's check that and see what the 1 there means. Int time. Okay, the number of time steps. The size of one time step is defined by the Greenfoot environment, the speed slider. Okay, so that does work to slow it down. It's not the most effective way, but I think the slider probably is a better way to do that. So that actually will work for to get the full marks for this question in the exam, I think. Now, there's another way to do it, because what we've done, we haven't actually used any of these methods given to us at all. And there's another way to do it using these as well, which if you understand these methods and how they work, this other way can be quite nice as well. So that's method 1 to do this. Let me quickly show you the alternative way to do this. We can just do, what was I thinking now of this other method? We can do it randomly, so it's going to be an int random number. I'm going to generate a random direction between 0 and 3. Okay, so int random number equals Greenfoot dot get random number. Okay, now 0 and 3, so put in 3 there. And now I'm going to set my direction as my random number. Okay, so that's going to be 0, 1, 2, or 3. And then I'm going to move. Right? So the move method will depend on what direction I've set. And I've just set the direction to be a random direction between 0, 1, 2, or 3. Okay, let me save that and run this. They should, okay. Aha, my icebergs are getting stuck at the top of the screen, which means my direction is not correct. My random direction is not correct. Right, let me pause that, reset. Let me go back to the code. Where is the code? Seems to have, I closed it. Iceberg. Random number set direction 3. Yeah, that's correct. Let me go back to the random number method. Let's see, did I random number, get random number? Ah, yes, it says it's exclusive. Okay. What that means is that if the limit is exclusive, so it does not include the number you put there. I put 3, so it will not include 3. It'll be 0, 1, or 2. Okay. Exclusive means do not include the number that you put here for the limit. So I'm going to put 4 there. So my current method will give me back a 0, a 1, or a 2, which means it cannot go 3, it cannot go south. Instead, I'm going to put a 4 there, so I can get a 0, a 1, or a 2, or a 3. So put 4. Right, save that. Let's run this. Hopefully now the iceberg should be able to move south occasionally. Yes, they can go up or down, left or right. They slow it very quickly, but again, that will work. Okay, let's slow it down. This one's a nice method because you can see that the icebergs stay on the tiles, whereas the previous solution to this, they can move anywhere across the screen, so on the lines. Okay, if they could cross the lines, they wouldn't stay on the grid. So that actually is probably a nicer solution, in the sense of it's more aesthetically pleasing. They stay on the grid, on the tiles. And the code here as well is pretty straightforward. Actually, just 3 lines. So it's actually less code there than the previous solution, because we now use all these methods given to us in the class. Anyway, I hope that makes sense for this class, to get the random movement of the iceberg. That actually, there's 2 methods there. I hope one of them, you can choose which one you think is the easiest to learn and use that in your exam. Okay, let me stop the video now, if I can see how to do that. Oh, the software seems to have crashed as well. Right, hope I can close this and stop the video. Where is it? No, don't say. There it is. Right, good.